Chapter 1, Functions and Applications, Section 1.3, Linear Functions and Models. Introduction. Linear functions are among the simplest functions and are perhaps the most useful of all mathematical functions. A linear function is the one that can be written in the form f of x equals mx plus b, or y is equal to mx plus b. The first one is known as function form. The second one is known as equation form. Here m stands m is the slope of the function and b is the y-intercept. Linear functions from the numerical and graphical point of view. Below we represent the function y equals to 3x minus 1 numerically. So to represent a function numerically, we represent a function in terms of a table. So table 1 represents the function above. From table 1, we notice that setting x equal to 0 give us y equal to negative 1, which is equal to b. Therefore, we can say b is the value of y when x is equal to 0. Or in other words, we can call b equal to negative 1 as y-intercept. We call b the y-intercept of the graph of the equation or function. Linear functions from the numerical and graphical point of view too. Below we represent the function y equal to 3x minus 1 graphically, as you can see here in figure 1. Slope of function. Change in a quantity. We denote any change in quantity by delta notation. If a quantity q changes from q1 to q2, the change in q is just the difference. So change in q, second value minus the first value of q, that give you the change in q, and we can write that delta q is equal to q2 minus q1. Having known about the delta notation, now we can define the slope. The slope is a measure of the steepness of a line or a section of a line connecting 2 points. So the slope m is equal to rise over run, or delta y over delta x. At the definition of a slope, the slope of a line is the ratio of the amount that y increases as x increases some amount. The slope tells you how steep a line is, or how much y increases as x increases. The slope is defined as a surface where one end is higher than the other. It is also the difference in the angle of the surface. The slope, if y is equal to mx plus b, then y changes by m units for every 1 unit change in x. Computing slope. We can compute the slope m of the line through x1, y1 and x2, y2 by the formula m equals y2 minus y1 over x2 minus x1. The slope of the line through point 13 and point 511 is evaluated using the formula above. M equals to 11 minus 3 divided by 5 minus 4, which is equal to 8 over 4, which is equal to 2. Also, the slope of the line through 1, 2 and 2, 1 is evaluated using the formula above. M is equal to 2 minus 1 divided by 1 minus 2, which is equal to negative 1. Computing y-intercept. The y-intercept of the line passing through x1, y1 with the slope m is given by b is equal to y1 minus mx1. Quick example. Find the equation of the line through 2, 3 with the slope of 4. First, we find y-intercept using the formula above. b is equal to 3 minus 4 times 2, which is equal to -5. Second, we use the slope-intercept formula to find the equation of the line. Y is equal to mx plus b. By substituting, we get y is equal to 4x minus 5. Example 2. Find the equations for the following straight lines. A through the points 1 and 2 and point 3 and -1. B through 2 and -2 and parallel to the line 3x plus 4y equal to 5. C horizontal and through the point -9 and 5. Vertical and through -9 and 5. Solution of example 2, part 1. Part A. To find the equation of the line, first we find the slope using the slope formula m equals to -1 minus -2 divided by 3 minus 1, and that is equal to -3 over 2. Second, we find the y-intercept by using the y-intercept formula. B is equal to 2 minus 3 over 2 times 1. That is equal to 7 over 2. Finally, by substituting in the slope-intercept formula, we find the equation of the line y is equal to -3 over 2 x plus 7 over 2. Part 2 of the solution. For example 2, part B. To find the equation of the line, first we find the slope. Parallel lines have the same slope. Solving the given equation for y, we get y equal to -3 over 4x plus 5 over 4. Therefore, the slope is -3 over 4. Second, we find the y-intercept by using the y-intercept formula. B is equal to -2 minus -3 over 4 times 2. That is equal to -1/2. Finally, by substituting in the slope-intercept formula the above result, we find equation of the line to be y is equal to -3 over 2x minus 1/2. Solution of example 2, part 3. Part C. The equation of a horizontal line through a point x1, y1 is given by y is equal to y1. Therefore, the equation of the line is y is equal to 5. Part D. The equation of a vertical line through a point x1, y1 is given by x is equal to x1. Therefore, the equation of the line is x is equal to -9. Example 3. The manager of the frozen air refrigerator factory notices that on Monday it cost the company a total of $25,000 to build 30 refrigerators, and on Tuesday it cost $30,000 to build 40 refrigerators. Find a linear cost function based on this information. What is the daily fixed cost and what is the marginal cost? Solution of example 3. We have 2 points. So point number 1 is 30 and 25,000, and point number 2 is 40 and 30,000. The slope is given by uh, delta y over delta x, or rise over run. So we have 30,000 minus 25,000 divided by 40 minus 30, and that gives you 500. The intercept is b, which is basically 25,000 minus 500 times 30, and that is equal to 10,000. The linear cost function is therefore Cx equals 500x plus 10,000. Example 4. You run a small supermarket and must determine how much to change for hot and spicy brand baked beans. The following chart shows weekly sales figures. The demand for hot and spicy at two different prices. Table 2. Price of a can, the demand can sold per week. So if you charge 50 cents for a can of hot and spicy, the demand for hot and spicy become 400 cans. But when you charge 75 cents, the demand for hot and spicy become 350. Model these data with the linear demand function. How do we interpret the slope and q-intercept of the demand function? Solution of example 4. Slope q2 minus q1 over p2 minus p1 equals to 350 minus 400 divided by 0.75 minus 0.50, and that is equal to negative 200. Intercept b is equal to 400 minus 200 times 0.5, and that is equal to 500. Therefore, the demand equation is equal to negative 200p plus 500.